Welcome to Spring LIB.
Let's solve the system of C1 and C2 first because they are in series. If you try to find the net capacitance of these two capacitors, you get C1 times C2 divided by C1 plus C2. In this case, I have denoted Cn as small cn here. Now, this small cn is in parallel with C3. In this case, I am using capital C sub n equals Cn plus C3 because they are in parallel. Their capacitances simply add up. C2 divided by C1 plus C2 plus C3. Since we know all of them have the same capacitances, this equation simplifies quite a lot, and that gives you 1.5 C. I have substituted C1, C2 and C3 with the value of C. Now, to find the net capacitance of this system with the capacitor of C4, we need to do the series capacitance because C4 is in series with all three capacitances. Now, the, the series capacitance is given by 1 over C net. I'm writing C net now, which is equal to 1 divided by Cn, capital Cn, plus 1 divided by C4. Since all of them have same capacitances, I have substituted C4 by C and Cn by 1.5 C. If you solve this by taking 1 over C common, you get 1.66 divided by C. So the net capacitance is given by 0.6 C, which is also 3 by 5 C. Now, part B asks you to find out how much charge is deposited on each of the capacitor. Now, as we know, for C4, which is in series with all other three capacitances, should have the same charge as other three capacitances combined. So C4 will have simply the C net times V of charge. So let's denote it by Q4. So Q4 will be 3 by 5 CV. Remember that C4 was in series, so it has all the charge of C net. Since in series capacitor system, all the capacitors have the same charge. Now, the system of C1, C2 and C3, that is C1, C2 and I'm sorry about that, C3 have the charge deposition of 3 by 5 CV. Now, as we know, all of them have the same capacitances, C, C and C. We found out that C1 and C2 have net capacitance of, let me calculate it further, C divided by C plus C, which is equal to 0.5 C. Let's use that. Now, this has 1 C. On the other hand, this system has 0.5 C. Now, so in this case, the net capacitance is 1.5 C. So, charge deposited on this capacitor, which is C3, is given by 1 by 1.5, which is net capacitance, times C. So, which is equal to, so this here is a net charge on these three capacitances. So, charge across C3 which is given by 1 by 1.5 of Q, which is 1 divided by 1.5 times 3 divided by 5 CV, which is equal to 2 divided by 5 CV. So Q3, that is charge across capacitor 3, is equal to 2 divided by 5 CV. Now, charge on the series system is given by 0.5 divided by 1.5 of Q, which is equal to 1 divided by 5 CV. So Q1 equals Q2 equals 1 divided by 5 CV. Okay, this is true because when capacitors are in series, they all have same charge distributed on each of the capacitor. Now, to find the voltage across each of the capacitor, what we need to do is V1, that is equal to Q1 by C1. So in this case, voltage, since C1 is equal to C, voltage is equal to I'm sorry about that. Q1 is substituted as 1 divided by 5 CV divided by C, which is equal to 1 by 5 V. Same is true for V2, that is voltage across C2, which is 1 divided by 5 V, since both of them share the same charge. V3, on the other hand, is different, which is equal to Q3 divided by C. C3 is equal to C, so let's not write C3 anymore. Now we found out that Q3 here was 2 divided by 5 CV. So you will get 2 divided by 5 V. V4 is equal to Q4 divided by C, which is equal to 3 by 5 V. From here, let me make this Q4. Thank you.